chapter 3 and 4 because we need the SS code.
I'm going to focus on chapter 3 today, answer and questions. Okay? Right here on the side, left side, right side. Do you see test chapter 3 and 4? So that's where you go and click on October 11th to take the test after I gave you passcode. All right. Now, before taking the test, you have to finish chapter 3 and 4 quizzes. Chapter 3 quiz is here. Chapter 4 quiz is here. Now, you should be doing that before you take the test too. So I'm going to go to module 2, chapter 3 and 4. Okay, I have the lectures on September 29, 22nd, 20, 22 September for chapter 3. And I'm going to go over these questions with answers for chapter 3. On Wednesday, I'm going to go over chapter 4 quizzes, chapter 4 answers and questions and answers. Then you will be ready for test 2 on October 11th here. So let me start with the questions for chapter 3. Okay, there's an older video right here. You can also go there and watch that one if you missed anything, because I cannot go over everything in detail. I think chapter 3 earlier video described first half of the question and answers thoroughly. So I'm going to go over them quickly, the beginning questions quickly, and focus on next half of the questions, okay? All right, let me go to chapter 3 questions. Chapter 3 is from radiation from sun. So the topics we covered is listed here. So based on this, we have certain questions. We also have some fundamental questions about chemistry. For example, question 1, what distinguishes atoms of one element from another? They have same number of protons. One element, atom of one element has specific number of protons. Answer is C. Number 2, nucleus of atom contains, by now you should know protons and neutrons. That's answer D. Electrons are outside the nucleus. The number 3, mass number of an isotope is sum of the number of protons and neutrons. That's C, sum of the number of its protons and neutrons. These are basic ideas that you need to know. Number 4, atoms of an element have same isotopes of an element. Isotopes are atoms of an element with different masses. Same number of protons, but different number of neutrons. So answer is B. Protons, same number, different number of neutrons. Therefore, we have carbon 13, carbon 12, isotopes like that. Carbon has atomic number 6, but they could have 2 isotopes with 6 neutrons or 7 neutrons, carbon 12 and carbon 13. Number 5, atomic number is number of protons in the nucleus. So that's a B. You have to know the definition. When you have isotope, there's an isotopic symbol. For carbon, 13 isotope. Carbon 13 isotope is a carbon with mass number 13. Atomic number is given on the subscript and mass number is in the superscript on the left side. So 13 means there are a total of 13 protons and neutrons. 6 means atomic number 6 protons. Therefore, there should be 7 neutrons. 7 plus 6 is 13. Therefore, number of protons is 6, neutrons is 7. Electrons are in the neutral atom. There's no charge on the symbol. Therefore, number of protons equal to number of electrons. Answer is C. So from the symbol, you can tell how many electrons, protons are in the isotope or particular element symbol. Number 7. For fluorine 19, atomic number of fluorine is 12. Atomic number is 9. I'm looking for my periodic table. Hold on a second, I got it. Atomic number of fluorine is 9. Mass number is fluorine 19 is 19. Therefore 10 neutrons. So 9, 10. That's the answer is D. And 9 electrons. Fluorine being neutral here. Okay. Number 8. How many protons, neutrons, electrons are in copper? 64 isotope. Now, normally we don't give atomic number as a subscript for the copper. Reason is you have a periodic table. If you look at the periodic table, copper is 29. So copper is 29 protons. That's the neutral atom, copper, 29 electrons. 64 minus 29 gives the neutron number, that's 64 minus 29 is 35. Answer is D. So that's how you calculate number of electrons, protons, neutrons. Okay, number 9. It is the blank electrons that account for many of the chemical and physical properties of our element. It's the outermost valence electrons. We call outermost electrons valence electron. Outermost is the answer. When one pair of shared electron is involved in covalent bonding, one pair is 2 electrons. It's called a single bond. Double is 2 electron pairs. Triple is 3 electron pairs. That's answer. Question number 11 deals with that. Single double, triple bonds have 2, 4, 6. That's the answer B. Number 12, elements in the same column in the periodic table, label A, tend to have similar chemical properties because they have same number of outermost electrons or valence electrons. Therefore, answer is A. The chemical properties of elements are chiefly due to number of outermost electrons. Even though protons decide number of electrons outside, but basically chemical reactivity is based on number of outermost electrons or valence electrons. In the periodic table, which element typically have similar properties? Those in the columns, in the same column has the same chemical properties, have similar properties, chemical and physical properties, mainly chemical properties. Answer is C. So we're going to look at electromagnetic radiation because we talked about UV radiation in the chapter, radiation from sun. So we have to know properties of electromagnetic radiation. Electromagnetic radiation is described as particle or wave. Particle properties are called photons, are the particles of light. They behave sometimes like small particles of photons or waves. So light behaves both particle and photon view as a particle wave description or wave. Therefore, answer is C. We describe electrons as particle or a wave. Number 16. Arrange these type of radiation in order by increasing energy per photon. We are dealing with that as a particle. Gamma rays, infrared, radio waves, visible light, UV. Increasing order of. So on the right, you have to have the highest energy. Highest energy is gamma. On the right, gamma radiation is found in ABC. So gamma, next to gamma is UV. Next to UV is visible. Then next to visible is infrared. Next to infrared is radio waves. So answer is B. That's the correct order. You can look at the diagram in the question 17. You can see that gamma rays have the shortest wavelength and the radio waves have the longest wavelength. Longest wavelength is least energy in terms of energy. Number 17. The diagram shows electromagnetic spectrum. Which type of the electromagnetic energy has the shortest wavelength? Gamma radiation. Gamma has the shortest on the right side. D is the answer. In the diagram above shows forms of radiation which cause sunburn. Sunburn is caused by UV light. So UV light is affecting skin, causing sunburn. B is the correct answer. Which of these electromagnetic waves travels the fastest in air. All electromagnetic radiation travels in the same velocity of light. So therefore, all are the same. Number 20, which of the following are not part of electromagnetic spectrum? Sound waves are not electromagnetic waves. They travel through the air. Electromagnetic radiation is different, fluctuation in electric magnetic field. So, except sound waves. Which color in the rainbow has the shortest wavelength? Shortest is highest energy. So in the blue is the one with highest energy. The visible spectrum is labeled as VIB-GEO: violet, indigo, blue, green, yellow, orange, red. Violet has the highest energy or shortest wavelength. Therefore, blue is shortest wavelength. Okay, what is the wavelength? Wavelength is the distance between peak of one of the wave to the next, distance between successive peak in the wave, successive peaks. So between two successive peaks. What is the speed of light in the air? The speed of light in the air is independent of wavelength or frequency. All radiation have same speed of light, 3.0 10 to the 8 meters per second. In reference to wave, frequency is number of waves passing a fixed point in 1 second. You stay on a 1 point, how many waves are passing over 1 second? Frequency is measured in 1 inverse S inverse minus 1 or 1 OS. It's same as hertz. Wavelength of the light in the visible region is about the size of an animal cell and a virus. That's about the size of a visible range, microns to nanometers. Calculate the energy of a wavelength and frequencies. Energy from wavelength and frequencies. Yellow light has a wavelength of 580 nanometers. What is the frequency of this light? There's an equation called C is equal to nu lambda. Nu is the frequency, lambda is the wavelength. If you calculate in frequency here in this problem 26, frequency is C divided by lambda. Therefore, 3.00 10 to the 8 divided by 580 nanometers converted to meters. 3.00 10 to the 8 divided by 580 multiplied by 10 to the negative 9. If you plug that in your calculator, you get the answer 5.17 10 to the 14. The D is the answer. You can check that out. 3.00 10 to the 8 divided by 5.8 10 to the negative 9. You get that answer. Number 27. FM radios transmit at 93.5 megahertz. What's the wavelength of this radiation? Now frequency is given. Therefore, C divided by frequency is the lambda when you rearrange the C is equal to nu lambda. C divided by lambda. C divided by nu. Nu is frequency. C is 3.0010 to the 8 divided by 9.3. Mega is 10 to the 6. 9.3 times 10 to the 6. You get the answer B, 31, 3.1, 21.21 meters. Just do the calculation. C, 3.10 to the negative, 10 to the 8, 3. That's the velocity of speed of light divided by 9.3, 10 to the 6. You get this answer. 28. UVB radiation has approximately 10 to the 17 inverse second frequency. What is energy of a photon of this light? So energy is E is equal to H nu Planck equation. Therefore, Planck equation is 6.626, 6.626, 10 to the negative 34. That's a constant. You find them on the table. Velocity of light, not velocity of light. Planck constant multiplied by 10 to the 17 gives you answer B. Minus 34, 6.626 minus 34 for Planck constant multiplied by 10 to the 17 gives you 6.63, 10 to the negative 17. Emission spectrum of the sun and portions of spectrum. Percentage of the sun energy is absorbed by Earth is 10%. Do you remember sun 37% absorbed by, 47% is absorbed by Earth, 37% is reflected. So that's about absorbed by is 10%. The lower layers of atmosphere with range of wavelength of light is predominant. It's the infrared and visible light. So the first two has UV light. A and C is UV light. So therefore, wavelength range light is predominant on Earth is less than, the greater than 300 is lower energy. Infrared and visible light comes under around 300 nanometers, greater than 300 nanometers. So we're going to look into wavelength of light in increasing wavelength. Infrared has the largest wavelength. Ultraviolet has the lowest. Therefore, A is the answer. There are 3 radiations, correct? Increasing order of lambda is increasing on the right side. The wavelength of a light in the region of X-ray is shorter, is smaller than virus. Remember, we talked about visible light has about cell and virus is smaller than virus. X-ray has shorter wavelength. Which type of ultraviolet rays does the sun emit? E. Sun emits UVA, UVB, UVC. Highest energy is UVC, lowest energy is UVA. Now we're going to look into quantum model of atom. Which statement of electronic structure of atom is described by modern view? Electron occupy discrete energy levels. Electron energy is quantized. That's true. We are not looking for false statement. Electrons move freely in space. That's not correct. That's the incorrect answer, not part of the math. Energy of electron in a shell around the nucleus is quantized. Energy is released, absorbed when electron move from shell to another. So those are all correct except B. We're going to look at how the sun's radiation are harmful to human, while others are not. 3 regions in UV radiation based on energy impact humans in molecules and wavelength. On the its rate of change in molecules impact on it. So from 1974 to 2002. Now impact is on the white male is the highest. It's kept increasing because of the ozone layer is depleted gradually. White female has the second highest. Black male and black brown male and female don't have hardly any effect, 2.5. Now 7.5 to highest is 27.5. So 7.5 to 27.5 about if you do divide 27, the increase is 7.5 to 27, 20 divided by 27.5. 20 divided by 7.5. Then it's 18%. Let me do that calculation. Okay. Let me get it. Okay. 20%. The difference is 20. 20 divided by the beginning is 7.5. 20 divided by 7.5. It's about 20%. Now, what is the question? I'm not looking at it, right? Diagnosis, okay. All right. What are the chances a white male would be diagnosed with melanoma? So it's about chances of white male is about 27% higher. So others are like 7.5. So in this time period, it increased by 18%. 18% increase is 7.5 to 27. That's what it is. Okay, which region of the ultraviolet spectrum is absorbed least by atmosphere? UVA. UVA is the one that coming to Earth. UVA is the one that causes skin damage. Which statement is correct? 37. UVC is most energetic of three. UVA is most energetic, is A is wrong. UVB is most energetic, which is wrong. C is the correct answer. UVC is the one that breaks up oxygen molecules in the upper atmosphere. Number 38, genetic material of living organism is damaged by light in the region of ultraviolet, especially below wavelength 320. I am trying to turn it off. Okay, number 39. Which of the following is not true of ozone? It is just like regular ozone, regular oxygen. Ozone is O3, oxygen is O2. Number 40. Select the concentration of ozone in ground level. That's about that's about C. All of these are correct. It's very low concentration, 0.070. 1 hour is 0.09 standard. So that's C. Number 41. Select the concentration that is naturally found in at stratosphere, 12,000 parts per million, 12,000. 12 parts per million ppm. Stratosphere, 12 parts per million. That's the correct answer. Number 42, Chapman cycle, which produce steady concentration of ozone. Wave numbers, oxygen atoms into the cycle is UVC, that is greater than, wavelength greater than or equal to 242 by ozone molecules. It breaks up the oxygen atoms, UVC. Ozone in the atmosphere is important because it absorbs UV radiation. Okay, next question. The structure of ozone resembles, like water, this one, C, bent structure. Okay, law of conservation of mass is mass of the product is equal to mass of the reactant. The chemical equation of calcium carbonate being decomposed to carbon dioxide and calcium oxide. So this is mass of each product is equal to mass of the calcium carbonate. That's law of conservation of mass. Covalent bond result from sharing electron between two atoms, equal sharing and unequal. So there's a polar covalent bond, non-polar covalent bond. Non-polar is equal sharing and unequal sharing is polar covalent bond. 48. Which of the following statement contrasting covalent bond and ionic bond is correct? Covalent bond is associated with non-metals. Ionic bond is associated with metal and non-metal. Answer is D. 48. Which of the following statement concerning difference between ionic and molecular covalent compound or molecular compound is correct? Molecular compound contain 2 elements and ionic compound contain 3 or more elements. That's not true. Sometimes covalent molecular compound also contain more than 2. Ionic compound contain oxygen and molecular compound. That's not true. Molecular compounds possess molecular unit and ionic compound don't. So that's the correct answer. Ionic compound doesn't have a molecule, but ionic solids. So correct answer is C. Covalent and draw the Lewis structures about covalent compound. The Lewis structure of the HCl is D. Lewis structure need to have 8 electrons or 4 electron pairs, because when you add 7 plus 1 valence electron in hydrogen and chlorine, you get 8. Therefore, 8 electrons need. Others have less than 8 or incorrectly bonded. Chlorine need to have octet and hydrogen need to have duet. Correct answer is D, 450. Which is one of the more Lewis structures of ozone? In ozone, there's a double bond between 2 oxygen atoms and a single bond. So you have, it could be D is the correct answer. C look like D also, but it has 1 oxygen in more than an octet of electron. C is not correct answer. Between C and D, D is the correct answer. Which of the Lewis structure of formaldehyde? Carbon bonded to 2 hydrogens and oxygen. So the total number of valence electrons is carbon has 4, hydrogen has 2 each, 4 plus 2 is 6, oxygen has 6. Therefore, 12 electrons. So 12 electron is 6 pairs. If you look at this D, 1, 2, 3, 4, 5, 6, that's have 12 electrons, so 6 pairs. And octet to carbon, so oxygen. So that's the correct Lewis structure. Valence electron of a representative elements. This is the numbers with A, group numbers with A, representative elements. Located in the outermost shell, occupy energy level. Valence electrons are located in the outermost shell, occupied by major energy level. Okay, that's the correct answer. Which of the following pairs of elements and valence electron is correct? Aluminum is 3A group, that's correct. Bromine is 7A, 7 is correct. Sulfur is 4, that's correct. That's not correct. Sulfur is 6, 6A. Sulfur cannot be 4 electrons. Strontium is 2A, that's correct. Thallium is in 3A in the periodic table. So sulfur is not correct, incorrect. 55, chlorofluoro hydrocarbons rise to stratosphere. So they interact with UV energy to produce free radicals that destroy ozone. You heard about that. CFCs break up ozone, which contribute to the ozone hole. B is the correct answer. Chlorofluorohydrocarbons. Which products contain ozone depleting substances? Motorbikes, no. Car AC, yes. Refrigerator, yes. Pesticide, fire extinguishers. So I'm not sure about 4 ions, how the ions contribute to that. Answer is C. 2, 3, 5, 6, 7. Oh, okay, I have taken 4 here. Cars, sprays, refrigerators, pesticide has also chlorine compounds, and fire extinguishers also. That's answer C. The depletion in ozone layer is caused by D, chlorofluorocarbon, chlorofluorocarbon. And ozone depleting substance is mainly used in cooling. That's the only thing. Manufacturing foam products. All human activity, the chimneys, no running, burning fossil fuel, nothing to do with ozone depleting substances. That's a D on air conditioning. CFCs are greenhouse gases that have caused rise in global temperatures. Name the CFC used in refrigerators. Freon is the answer. Number 61. Where was Freon used prior to ban on CFCs? Air conditioners. What type of compound can damage the ozone layer? Chlorofluorocarbons, CFCs. Some pesticide, but main compound is CFCs. Where do CFCs come from? All of the above. Spray cans has some fire extinguishers, air conditioners, manufacturing foams. There are little in each, and mostly air conditioning have CFCs. True or false? The CFCs were banned in developing countries by the year 2000. Yes, true. Which of the following compounds, number 65, useful for putting out fires and do not deplete stratospheric ozone? Halon is a Bromine compound replacing chlorine in the CFCs. Halogens are brominated compounds. Therefore, bromine doesn't have that much of effect on ozone layer. So it's heavy. Therefore, we use halon, bromine analogs of CFC to put out forest fires. Why are HFCs? Hydrofluorocarbons, no chlorines in them. Inappropriate, but they are not inappropriate for long-term replacement. They absorb infrared radiation because they are greenhouse gases. HCF, HFCs are also greenhouse gases. Therefore, it's not good on the long run. In what year will the production of importation of HCA, hydrochlorophore, end in the United States? 2015. What is the role of polar stratospheric cloud on the destruction of ozone? We talked about this in Antarctic region. Chemical reaction occur in this cloud. Help do not damage to those. Chemical reaction occur on the cloud that covalent convert molecules that do no damage to those. I think this is wrong. Chemical reaction occur. The PSC clouds help destroy the ozone. So answer is A. The coal clouds react with ozone to make oxygen molecules and oxygen atoms that break up the, right. During the Antarctic spring, oxygen is destroyed at a greater rate than it is formed. On the surface, Antarctic spring process is catalytic. Polar spheric cloud, that happens in the Antarctic spring. That's all of the above. The global goal of the Montreal Protocol in 1987 was to cut down everything, reduce production of chlorofluorohydrocarbons in developed countries, recycle chloroform with minimum release, encourage research to substitute. So all of the goals of 1987 Montreal Protocol. HFCs, hydrofluorocarbons without chlorine. Which compound is a HFC? The one without chlorine is C. CF3 carbon hydrogen fluorine is the HFCs. Answer is C. Number 72. The ozone hole is most prominent over D, Antarctica. The two chemical bonds and geometry of the water is best represented by C. Water molecule has two OH bonds, like in C. Number 74. About the Chapman cycle that keep the steady rate of ozone. What is the part of Chapman cycle in the atmosphere? Which are parts? Ozone is removed from the reaction with water. That's not a part of, we are not talking about Chapman cycle with water. Ozone is removed by interaction with UV. That's true. Ozone is react with oxygen atom to form oxygen molecules. That's true. That 2 and 3 are parts of. Free radicals are highly reactive chemical species. Unpaired electrons. They have unpaired electrons. Species such as hydrogen atom OH radicals with unpaired electrons, all these are correct description of free radicals. Decreased atmospheric ocean concentration may lead to melanomas, harm young marine life, increased occurrence of cataract, all of those, increase ozone, decrease ozone concentration can contribute to all these. Result of Montreal Protocol include all of these. Reduce CFCs, increase alternatives for CFCs, recycle and CFCs, that's all of them. Number 78, halons are the bromine, I talked about that, C, bromine replaced chlorine, some of the chlorine atoms, that's the halons. Now we're going to talk about metric unit. So this kind of a detail, what the correct relationship between milliliters and microliters. You cannot each one to one of these. For example, you have to convert 1 milliliter to 100 to microliters. So you get 1,000. I got 1,000. If you convert, all others don't give the equal numbers on the both sides. So only C gives equal numbers. Mathematical meaning associated with centi, milli, and micro is B. Centi is -2, milli is -3, micro is -6. Which of the following sequence are metric system listed of order of decrease in size? Deca, kilo, kilo, deci, mega, kilo, micro is the correct answer. In which of the metric system prefixes and power of 10 is paired correct? Kilo is 10 to the 3, not -3. Deci is 10 to the -1. Pairing is incorrect. More than one correct response. Therefore, A and C is incorrect. Micro is correct. When you have more than two incorrect response, you have to pick up D. In which of the following pairs of units first listed at 100 times, 1,000 times larger than the second? Milli and nano. That's not true. Kilometer and megameter, that's not true. Liter and centiliter is not true. That's no correct response. What metric relationship is incorrect? 1 milligram that's incorrect. 1 deciliter is 100 milliliters. 1 kilometer is 100,000 meters. Centigram. Milligram is incorrect. Longest distance. You have to convert all these distance to the same unit. You will find out D is the correct answer. That's the highest value. You have to convert each one to meters and find out which one is the biggest. Number 86. Ozone molecules break apart of lower wavelength than oxygen molecules. So why is that? Because oxygen has a double bond and an ozone molecule has a bond between double and a single, weaker bond. Ozone oxygen breaking is easy, broken by UVB. Ozone, unlike ozone, oxygen is broken by UV light. That's the D. The average bond in ozone is shorter. Oxygen is shorter than the average bond on ozone. Ozone is easy to break. UVC only break oxygen bond. UVB breaks ozone. Why UV radiation is higher in summer? Because sun is closer to planet Earth, so more UV light can come and reach us. What should you do to protect yourself from harmful radiation of sun? All of the above. Wear sunglasses, wear sunscreens, stay in shade, all of the above. What type of solar radiation is potentially damaging to the eye? UV. Answer C. What type of radiation are dangerous? Both UVA and UVB. UVC doesn't come to Earth. It's destroyed by oxygen in the atmosphere. Number 91. The safest sunglasses are made out of what material? Polycarbonate. What is the most immediate danger to children's eye from extreme exposure to sun? Photocataracts. B. When buying sunglasses, look for those what percentage of UV. That's C. 99 to 100%. So UV protected sunglasses are good for you. People who work in the following jobs are at increased risk: UV damage. Lifeguards, they work in the sun, stay on the beaches. Toll booth operators are no, because they stay inside. What else can I do to cut my exposure to UV rays? All of the above, both of the choices. Wear a brim hat, stay indoors during peak hours. Peak hours are 10 to 4, 10 a.m. to 4 p.m. Adding UV coating to prescription glass in which of the following is very inexpensive compared to things you buy. As the ozone gets more, hole get more pronounced, with time, one expect to incidence of cancer increase worldwide. That's the answer. Montreal Protocol is a treaty protecting global warming. No, that's about ozone depletion, CFCs. B is the correct answer. Treaty to reduce amount of CFCs in the world. Kyoto Protocol is to cut down carbon dioxide. Montreal is to cut down CFCs. What is the relationship between stratospheric oxygen level of atomic chlorine and ozone? As chlorine increases, ozone decreases. In that, CFCs go to the stratosphere, they move up, break down to chlorine-free radicals, they break down, chlorine-free radicals can break down ozone. That question don't have a number. Stratospheric ozone is destroyed and form in the same rate. About Eket and above Arctic in its early fall. That's where they are equally produced and destroyed. They have a steady state. 100. Ozone layer is found in stratosphere. That's number C. Okay, number 109. The Earth atmosphere, where ozone is found, is stratosphere. D. When it reaches largest size, the one ozone hole over the Antarctic was about size of North America. That's what the size of North America is. United States and Canada. The global production of CFCs fell down since Untitled Protocol. So how much it is reduced? From 1200 to 100. That's about 80%, 88% reduction. Which product of the ultraviolet decomposition of CFC act as a catalyst for ozone decomposition? Chlorine atoms. Also, CFCs react with UV, produce chlorine atoms, free radicals that destroy the ozone, decompose ozone. HCFCs have been developed to replace CFCs. In H is hydrochlorofluorocarbon. Some of the chlorines are replaced by hydrogens, chlorines. Environment is superior to CFCs. What property of? They have less chlorines. Greater reactivity and tend to decompose at high elevation below the ozone concentration is maximum. The greater reactivity of hydrofluorocarbons decomposed lead to, what was the question? What has been, HCC have been developed to, what the property of these new make them environmentally? I'm looking at it. They do not contain chlorine. They still have Cs, some Cs. They are high molecular weight than no. Lower reactivity makes them stable even at the ultraviolet. So greater reactivity lead to decomposition of high level because lead to, so they decompose before reaching the high elevation A. HCFCs are a temporary solution to the problem of ozone depletion and will be replaced over next 20 years by which class of compounds? HFCs. There's no chlorine anymore. What are FCs? Environment why are their environment superior to currently used HCFCs? Do not have chlorine, therefore no chlorine-free radicals produced. CFCs were originally developed to replace the refrigerant in refrigerant compound, ammonia and sulfur dioxide. Smelly gases were used in refrigeration before CFCs. What is special about South Pole versus North Pole that lead to depletion of ozone in South Pole? Polar stratospheric cloud form almost exclusively in the South Pole, and lower temperature help to break down the ozone. Which of the following is the most biologically damaging type of radiation? UVC. If it doesn't reach Earth, but it's more biologically damaging, UVA and UVB. The hours of day when you are most at risk from the sun's rays are 10 a.m. to 4 p.m. The best way to protect from the sun's rays, all of the above: wearing sunglasses, sunscreens, stay out of sun during the peak hours. Sun index is a forecast of UV radiation tied to the local weather forecast. We talked about UV index. What common medicine can make you more sensitive to sun? All of the above. Sulfur medication. These two, ibuprofen and all the medication in here. Best type of sunscreen to use, all of the above. Either spray, gel, or lotion. It's better than nothing. Sunscreens work by all of the above. Attracting sun rays, absorbing, reflecting sun rays, scattering. Which of these clothing choices offer the best protection and comfort from UV rays? C. Long pants, woven fabric, and loose fitting, long sleeved shirts. If you work outdoors, outside or otherwise spend a lot of time in the sun, what kind of hat? So canvas hat with the brim all the way around is best for you. What is the ozone layer located? Where is the ozone layer located? Stratosphere. Why is ozone layer important? It absorbs UV light and prevent from getting cancer, skin damage. What is the hole in the ozone layer? Where is the ozone layer located? Hole in the ozone layer. C. Over Antarctica. True or false? Sunlight damages the ozone layer by breaking up ozone into oxygen. Sunlight doesn't damage ozone layer. It's UV light. Which of the following is the not consequence of ozone layer depletion? Tidal waves. Tides are caused by global warming, caused by carbon emissions. When was the first ozone hole discovered? When was the first ozone layer? 1970s. C. In which sphere ozone layer is found? That's the same answer, B. Montreal Protocol is related to ozone layer depletion. All right, we have done the problems on chapter 3. Do you have any questions? Are you guys there? If you have any specific question, I can go over. Let me know. Are you guys there?